Hello and welcome to my presentation on the physics of LCDs, including the polarization of light. In 1888, Frederick Reitzner, an Australian plant scientist, discovers liquid crystals while studying a chemical called cholestyrylbenzoate. It seems to have two distinct crystal forms, one solid, one liquid, each with its own melting point. Building on that, German chemist and physicist Otto Lehmann coins the term liquid crystals and carries out more detailed research using polarized light. RCA's Richard Williams begins to research the optical properties of pneumatic liquid crystals. He files his groundbreaking LCD patent on November 9th, 1962, and it's granted almost 5 years later on May 30th, 1967. In the 1960s, RCA engineer like George Heimler built on his theoretical research to produce the very first practical electronic displays, hoping to create LCD televisions. Then in 1968, RCA publicly unveils LCD technology at a press conference. The New York Times quoted a thin television screen that could be hung on a living room wall like a painting. In 1968, a French scientist, Pierre Gilles, carries out groundbreaking research into phase transition involving liquid crystals, for which he wins the Nobel Prize many years later in 1991. RCA's Wolfgang Heilfrich develops twisted pneumatic LCDs based on polarized light, but the company is skeptical and shies away from developing them. At Kent State University, James Ferguson develops and patents an alternative version of the same idea. Today, Helfrich, his collaborator Martin Schatt, and Ferguson are jointly credited for inventing the modern LCD. In 1970, having failed to commercialize the LCD, RCA sells its technology to Timex, which manages to popularize the LCD in the first digital wristwatches. In 1973, Sharp unveils the world's first pocket calculator. Then, in 1980, super twisted pneumatic displays appear, with far more pixels offering higher resolution images. Until 1988, about 100 years after the discovery of liquid crystals, when Sharp produces its first 14-inch color TV with a LCD display. Now in the 2000s, 2010s, optical scientists experiment with more efficient, richer color LCDs based on quantum dots or plasma televisions. At any given moment, liquid crystals can be in one of several possible substates, somewhere in a limbo between solid and liquid. The most important liquid crystal phases are called pneumatic and smectic. When they're in the pneumatic phase, liquid crystals are a bit like a liquid. Their molecules can move around and shuffle past one and each other, but they all point broadly in the same direction. If you cool the liquid crystals, they shift over to a smectic phase. Now the molecules form into layers that can slide past one another relatively easier. Polarized light waves are light waves in which the vibrations occur in a single plane. The process of transforming unpolarized light into polarized light is known as polarization. So if there's a light beam shining through a polarizer, the light shining in the X and Y. So as it goes through the polarizer, it filters out either the X or Y light, depending on which direction it's facing. In this case, it's facing up and down, so it's X. Pneumatic liquid crystals have a cool trick where they can adopt a twisted up structure, and then when you apply electricity to them, they'll straighten out again. In an LCD TV, the pixels are turned on and off electronically using liquid crystals. So, at the back of the screen, there is a large bright light that shines outward towards the viewer. In front of the screen, this light, there are millions of pixels, each one made up of smaller areas called subpixels that are colored red, blue, or green. Each pixel has a polarizing glass filter behind it, and another one in front of it at 90 degrees. That means that pixels normally look dark. In between the two polarizing filters is a tiny, twisted, pneumatic liquid crystal, as you could see in this diagram. That could be switched on and off, which means twisting it or untwisting it electronically. When it's switched off, it rotates the light passing through it 90 degrees, allowing the light to pass through the next polarizing filter. When it's switched on, it doesn't rotate the light, which is blocked by one of the polarizers, and the pixels look dark. Each pixel is controlled by a separate transistor or a small electric component that can be switched on or off many times each second to produce a moving picture on a screen. LCDs are used in pretty much most modern day things, including TVs, monitors, instruments, aircraft, cockpits, phones, and like many more devices. So without LCDs, we'd probably have, definitely worse TVs, but everything would also be a lot more expensive because this is currently one of the cheapest ways to produce like monitors and screens like this. So that's kind of the technology impact. Smart, we're excited. Have a nice day. Thank you for watching my video. Goodbye.